Hey, what's going on, guys? Let's do this problem right here. Let's do the ratio test for this series to find out whether this series converges or diverges. So how to do the ratio test? So the idea is we take limit n approaches infinity and an plus 1 over an. So an plus 1 is basically mean wherever we have n, we just add 1 to that one. So here we are going to add limit n approaches infinity, and this is going to be n plus 1 times minus 3 power, we have n right here, so we are going to add 1 to that one, and in the denominator also we have power n, so we are going to add 1 to that one, minus 1, and then we divide this one by original function. So dividing this one is same as, so we take absolute value, so that's also another condition, we have to take absolute value. So dividing by this one is same as multiplying by the reciprocal of this one. So this is going to be 4n minus 1 over n power minus 3 power n, right? So if you divide, this will flip around and go to the top. So that's the same thing. So here what we are going to get is limit n approaches infinity, and this is, so you can see that if you expand this one, this is going to be minus 3 power n times minus 3 power 1, right? So what you can do, we can cancel this one, 3 power n and this one, and write minus 3 power 1 on top, because we have minus 3, 1 is left, so this is same as minus 3 power 1, and we have n in the denominator, and this one plus 1 minus 1, both of them become 0. If you add them, that's going to become 0, so you can cancel these two. And then we have 4 power n minus 1, this is same as this one. If you expand this one, this is going to be 4 power n times 4 power minus 1, right? So here we can cancel 4 power n, 4 power n, so we are going to have 4 power minus 1 on top. So this is going to be 4 power minus 1 on top, and in the denominator we have n plus 1, that's not cancelled in the numerator, so n plus 1 in the numerator, and in the denominator we only have n left when we do all these things. So here what we can do, if you see 4 power minus 1, it's same as 1 over 4, right? When you write 1 over 4, that's power 1, and if you bring that one to the top, that's 4 power minus 1. So you can write this one, limit n approaches infinity minus 3 over 4. I brought this 4 to the bottom, and in the numerator we have n plus 1, in the denominator we have n. So here what we can do, we can move all the number to the front. So here if you take some value out of the absolute value, that's going to be positive. So here we have negative 3 over 4. If you bring in front of the limit, that's going to be positive 3 over 4. And then we take the limit n goes to infinity, and we are going to have n plus 1 over n, right? Now we have to find the limit of this one. And as you can see that the power of both of them are same. So when you have power in the denominator and power in the numerator are same for the highest power, the ratio of that one is going to be the limit. So here in front of this we can see that this one, when you don't have anything, it's 1. So the limit of this one is going to be 1 over 1. But the limit is going to be 1. But then we have 3 over 4 in front of this. So we have to multiply this one by this one. So this is going to be, the final value is going to be 3 over 4. So when we do a ratio test, and if we get a value that is less than 1, that means this series is convergent, right? For example, if you get more than 1, that's divergent. If you get equal to 1, no conclusion. So here we are getting less than 1, so this is a divergent series. Convergent series. Less than 1 is convergent. If it's more than 1, divergent. So convergent series, and that's how we find out whether a series is convergent or divergent using ratio test. I hope you guys find this video helpful. See you next time.